Good evening. Today we're going to be talking about operations with rational numbers. Our key concept, we're going to start by evaluating expressions. And we have the distributive property that we're going to work with today. So if we have any numbers, A, B, and C, if we have A times the quantity B plus C, we can distribute and do A times B plus A times C. If we have distributive property with subtraction, it would still be A times B, giving me AB, minus A times C. Okay? And the order of operations. First, we're going to evaluate expressions inside the grouping of symbols. Then we're going to evaluate the exponents. Then we're going to multiply and divide from left to right. Then we're going to add and subtract from left to right. And that is important when we have to go from left to right. Don't do all of the multiplication first, then do the division. You have to go from the left to the right as you're reading the book and work through it that way. And you guys remember this. PEMDAS, parentheses, exponents, multiply and divide from left to right, add, subtract from left to right. So let's start with the first example, example 1. They want us to simplify negative 5 times 3 plus 2 plus negative 4. So first let's do it using order of operations. I'm going to rewrite my problem. Order of operations would tell me to do what's inside the parentheses first. So I'm going to rewrite everything I don't use. 3 plus 2 is 5 plus a negative 4. Now I have to do multiplication. Negative 5 times 5 is negative 25. Rewrite my plus negative 4. So when I combine my two integers, they have the same sign, so I'm going to add them and keep the sign, and I get negative 29. Now, using the distributive property, I should still get the same answer. So when I distribute here, I have negative 5 times 3, and I am going to write it out the long way first, plus negative 5 times 2, and then I'm going to rewrite my plus negative 4. So negative 5 times 3 is negative 15, plus negative 5 times 2 is negative 10, plus negative 4. Notice how I kept my negatives following the plus sign in parentheses so that I was clearly able to see what we were doing. So negative 15 plus negative 10 is negative 25, plus 4 is negative 29. I did get the same answer. Now, you can choose either way. For me, if I was working with just the integers like we were here, I would use the order of operations over the distributive property. When we get into a little bit more algebra later on, we're going to have to use the distributive property to simplify first. So the next two questions, I want you to circle the correct expression using the distributive property. I'm going to take it one step further. I want you to circle it, and then I want you to evaluate it and give me an answer at the end. And we'll check back in a minute. So for the first one, you can see that we have negative 6 times negative 1/2, and we have to add negative 6 times 1/3. Now let's practice our work with fractions and rational numbers here. A negative times a negative is going to give me a positive. 6 times 1/2 is the same as 6 divided by 2, which we know is 3, plus a negative times a positive is going to remain negative, and 6 times 1/3, I can simplify and get negative 2. So 3 plus negative 2 is 1. For my second example here, example number 3, when I multiply these, I get negative 10 times 5.8, rewrite my minus, and negative 10 times 6.2. When I do the math, I get negative 58 minus negative 62. That becomes 58, negative 58 plus 62, because I have to stop at the opposite, and I get an answer of 4. So again, I want want you to use the formula F equals 9/5 C plus 32 to convert a temperature given in degrees Celsius to degrees Fahrenheit, and they want us to complete the table. So let's do the first one together. We want to plug in -10 for degrees Celsius. So I'm going to write my formula first. And I'm going to plug in -10 for C. Now, I'm going to do a little bit of simplification here. 5 goes into -10, -2 times. So I have 9 times -2 is -18, plus 32. When I do my arithmetic on that, I get 24. On your own, please do the conversion from degrees Celsius to Fahrenheit of -40. I got -40 when I did that. I put in to -40 in for C. 5 went into -40, -8 times. 9 times -8 gave me my -72. And I had to add 32. My signs are different, so I'm going to subtract and take the sign of the larger. It gives me -40. Now we're going to work the opposite way. We're going to use the formula C equals 5/9 F minus 32. And we're going to convert this temperature 5 degrees Fahrenheit. So let's put 5 in. Notice I wrote my formula down first. Here's one of those situations. I have two options. I can either use the distributive property, or I can follow order of operations and do 5 minus 32 first. In this case, because I want to avoid having to work with a bigger fraction, I'm going to do 5 minus 32, which becomes 5 plus -32, which we know is -27. Now when I do that, I can clearly see I can simplify. Forget the blue pen on this smartboard. So -27 divided by 9 is -3. 5 times -3 is -15, and it is degrees Celsius. Okay. The next concept we've already done. This is review for us. A complex fraction is a fraction a over b, where a and or b are fractions and b can't be 0. So the expression -3/4 over 10 is a complex fraction. They're showing us the main fraction bar here, and then the one that's not the main fraction bar. I always draw my main fraction bar a little bit bigger. Okay, we do that to avoid confusion later on, and I recommend you guys do that as well. I actually almost exaggerate how big I make it. So let's look here. To simplify fractions, which we've done with complex fractions, we need to find an equivalent fraction where both terms, the numerator and the denominator, are whole numbers. Remember, again, this is not new for us. So we need to find the least common multiple of 4 and 7 by listing the multiples of 4 and 7. In this case, the least common multiple, we can just multiply them, and we get 28. And if you can't find the least common multiple, any multiple that they both go into, so if you couldn't figure out that it was 28, but you figured out that it was 56, you could use 56. You just have to do a little more simplification at the end. Okay? Then we're going to cross cancel if possible. Then we'll multiply the fractions on the numerator and the denominator. Okay? Then we'll simplify, and we'll go into simplest form. So let's look at this first one. We determined the LCM was 28. So they multiplied by 28 here. And notice it's clearly I'm multiplying the numerator here. Clearly I'm multiplying the numerator of 28 here. The numerator of 6 by 28 here. When I do this, 4 can go into 28 7 times. And 3 times 7 gives me 21. 7 goes into 28 4 times. 6 times 4 is 24. So I have 21 over 24. Now notice, my denominator is completely clear, and I was left with just a denominator of 1. If you're not left with a denominator of 1, you got to pick a different least common multiple. Okay, they have to clear. If they don't clear, you got to pick something else, but they will make it disappear. We want to make them easier. They're complex, but we want to make them easy. So now I'm here at 21 24ths. I can divide both the numerator and the denominator by 3, and I end up with 7/8. I love complex fractions. I can simplify them all day. A lock is a chamber used to move a boat from one water level to another along a river. After a boat enters the lock, the water inside the lock drains out, lowering the boat to the new level. So in this case, the water level drops 3 feet for every 2.5 minutes. So we have the rate of negative 3 feet over 2.5 minutes. Simplify this complex fraction and tell us what this means. Okay, so this is not completely workable here. I'm going to stick my negative up on the top in the numerator. We talked about that yesterday. We can stick it in the numerator or the denominator. I like my negative sign in the numerator. It clearly defines for me what I'm doing. We have to convert this. This becomes 5/2. The least common multiple of my baby denominators, if you want to think of it, this is a denominator here of 1 in the numerator. This baby fraction here has a denominator 1. This baby fraction here has a denominator of 2. So my least common multiple is 2. So I'm going to multiply my numerators by 2. Okay? And when I do that, that 1 is gone, so I have negative 3 times 2 is negative 6. Here, I simplify, and I'm left with just a 5. My original problem was given to me in a mixed number form, so I'm going to convert this back to a mixed number. So it'll be negative 1 and 1/5. And it was a rate of feet per minute. So what does this mean? Remember, negative is a direction, so it means the water level drops negative 1 and 1/5 feet per minute. Okay? Let's go on to our last page. I want you to simplify number 7 on your own and join me in a minute. So when I did my arithmetic, I found my least common multiple to be 6. So I multiplied this numerator by 6, and I multiplied this numerator by 6. In the top, the numerators, or the 6's canceled, and I was left with negative 5. In the bottom, 2 went into 6 3 times, right here, and 15 times 3 was what I was left with. When I did my arithmetic, I got 45, and then I simplified to get negative 1/9. Now, a fraction bar is a grouping symbol as well as the division symbol. In the expression 2 plus 4 over the 3, the fraction groups 2 plus 4 first and indicates that you add 2 to 4 before you divide by 3. Let's cross this out because it's hard to read. It's 2 packed together. So I have 2 plus 4 over 3. So I need to do 2 plus 4 is 6, divided by 3. And as we know, 6 divided by 3 is 2. And here we go on to our last one. So we want to use that concept to simplify this complex fraction. So I have negative 5/6 all over 1/3 minus 1. Order of operations tells me I have to take care of this denominator first, 1/3 minus 1. I can't just dump the negative 5/6. I've got to carry it along while I do my work. So when I'm subtracting here, or adding the opposite, I can make this 1/3 minus 3/3, which I would stop in at the opposite. So in the numerator, I'm left with negative 5/6. And in the denominator, 1 plus negative 3 is negative 2 over 3. Now I can work by finding my least common multiple of 6 and 3, because they're the baby denominators. So it's 6 times 6. These 6's here cancel, I'm left with negative 5. 3 goes into 6 twice, and I'm left with negative 4. And a negative divided by a negative is positive, so it's 5/4. And let's convert this into 1 and 1/4. That's the end of our lesson for today. If you have any questions, review parts of the video if you were stuck on something, and we're going to practice these much more tomorrow. Have a great night. I'll see you guys tomorrow.